Hello, my name is Vignesh Kumar, and this is going to be the third video in the math lecture series for the SAT math section. And today we're going to be going over percent, proportion, and rates. So these are three different topics, but we're going to be going. They're all three of them are very similar topics. So we're going to be going over these three topics in like the same video. So first we have percent and percent. There's two types of questions that percent will ask you. The first one is where they'll give you a data set and they'll ask you to like find a percentage of like how an outcome happens, and for that it's just specific outcomes over total outcomes. That's like the first way you get asked a percent question. Other major way you get asked a percent question is to like increase a number by 20% or decrease a number, and like that sort of thing. So like obviously there's more advanced questions like that, but it's like those two are like the main ways you get asked percent questions. Next, we have proportion questions, and this one is basically most likely it's going to be used in like to like they give you an equation like an area equation, and then they ask you to like change one of the variables, and then they ask how that affects another variable. So like the example I gave here is if you increase the radius by 20%, how does that affect area? So you have the area of a circle equation. You and you basically just followed the logic I did right here, and eventually you'll get a 1.44a. So you know that the area increases by 44%. Also, as usual, these notes are going to be posted on Google Classroom alongside this video. So I highly recommend you go over these notes as well as do the practice problems I attached at the end of these notes. I attached a lot of practice problems this time, so hopefully you guys get some good practice. And the third topic we're going over today is rates. And the most common use for rates is that they'll give you a rate, and then they'll ask, and they'll say what if you change something in the rate, and they'll ask for what the answer is. So I may have explained it weird, but I'll give you an example. So let's say they say Jeb runs a mile in 10 minutes. Then they'll ask how many miles will he run in 60 minutes, or they can ask how many minutes does it take for him to run 10 miles if he runs at a constant rate. So that's basically the types of questions they'll ask for rate, and you'll see what I'm saying here in the practice questions that we're gonna do, and that hopefully you guys do on your own. So let's go over some percent questions first. So the first one I'm gonna go over is number one. If x is 50% larger than z and y is 20% larger than z, and then x is what percent larger than y. So the first thing you want to do is to write this out into equations. So first, x is 50% larger than z. That means x is equal to 1. Sorry, let me write this smaller. Like, let me just make this bigger. So x is equal to 1.5 z, and y is equal to 1.2z. If you want to know how I got 1.2, I did because 20% is just 0.2, and I added 1 because it's increasing. If it was decreasing, I would have done 0.8 because I would have taken 1.00 minus 0.2. So yeah, but right now I have these two equations, and the easy way to solve this is just let z be any number, and I'm going to let z be 12. Sorry, let z be 10. So now I'm just going to solve for x and y, and then I can figure out x is what percent larger than y. So that would give me 1.5 times 10, which is going to equal 15. And this would give me 1.2 times 10, which is going to give me 12. So now that I have x and y, I just do x over y, which will give me 1.25. So now I know that x is 25% larger, and that's number C. So if you want to know how I got 25, I just did minus 1 to give me 0.25 or 25%. Okay, then so that was like the first question type I showed you, like I explained to you as earlier. Now the second question type is with the data set. So let's look at this. Let's do number 6, and number 6 is for this data set. So the table below shows the number of box springs and mattresses units sold over 4 weeks at a bedding store. So we have this table over here. And now let's get the question, number 6. Number 6 right here. Mattresses accounted for approximately what percentage of all units sold during week 1? So the reason why this question is actually a tricky question is because it says of all units sold during week 1. So it's not asking for you the total number of units of all 4 weeks, like some may assume. It's asking specifically that it's out of units sold during week 1, which is 85, and you want to know mattresses accounted for approximately what percentage. So that means mattresses is 47. To define the percentage, it would just be 47 over 85, and that would give you like it would be like 0.552 something, I think, and that's the closest to 55.3%. That's why number 6 is D. Now we're going on to the second topic, proportion. So yeah, I'm also going to do 2 questions here, and I'm also going to do number 1 here. Electric power P is related to the voltage V and the resistance R by the formula above. If voltage were halved, how would the electric power be affected? So here again, you could just plug in values for P, V, and R and just solve that way, and you would see how P changes. So for example, let's say you make P equal 1 and V equal 2 to make it easy, and R equal 1. So the first, if it's not halved, it would be, wait, actually, sorry, never mind. Sorry, so, sorry, we disregard what I just said. So we don't let P equal something. So let X, sorry, let V equal 2 and let R equal 1. And so that would be P equals 2 squared over 1. And that would be 4 over 1, so P equals 4. And now let's do it if V equals, because we're having it, right? So now let's do if V equals 1. So that'd be P equals to 1 squared over 1, which is equal to 1. So if we see P was quartered here, like it was cut into like four pieces sort of. So where is that shown? That's in answer choice D. Next, we're gonna go over number 8. It's the last question in this problem set, and it refers to this equation right here. So I'm gonna show put this equation right here. L equals 4 pi d squared b. The total amount of energy emitted by a star each second is called its luminosity, L, which is related to d, its distance, meters away from Earth, and b, its brightness measured in watts per square meter by the formula above. And number 8, astronomers, yeah, sorry, I don't think I said that right, see 2 equally bright stars, star A and star B, in the night sky, but the luminosity of star A is 1/9 the luminosity of star B. The distance from star A from Earth is what fraction of the distance of star B from Earth? So basically, the star A. So basically, you have Earth right here. I'm sorry, that looks like Earth. I'm trying to mark it E. Okay, I don't know why this is glitching out real quick. So you have Earth right here, okay, and now you have 2 stars. You have A right here, and you have B right here. So A is 1/9 the luminosity of star B. So what does that tell you? It tells you that A is, I mean, that means A is, what's it? Sorry, that means A is is closer to Earth than B is. So that means the distance here is shorter, and we know that because it asks the distance of star A from Earth is what fraction of distance from star B from Earth. And we also know because if you look at the equation, D is directly related to L. So we know that the luminosity is 1/9. But the easy way to, and we know D is the only variable that changes. However, since D here is squared, that means we know that they have a square relationship. So what we can tell from this is that if you change D and you square it, that's the change in L. So what number squared equals 1/9? That's 1/3, because the square root of 1/9 is 1/3. So that's why answer choice C is the correct number there. Next, I'm going to be going over number 9 of the second part of the rates problem set. By 1 o'clock, a total of 40 boxes has been unloaded from a delivery truck. By 3:30 p.m., a total of 65 boxes had been unloaded from the same truck. If boxes are unloaded from the truck at a constant rate, what is the total number of boxes that will have been unloaded from the truck by 7 p.m.? So this is a simple rate question where it tells you like 2 points, and you have to find the rate, and then you can like use that with a different variable. So first we have at 1 p.m. there were 40 boxes. At 3:30 p.m. there were 65 boxes. So that means the difference in time was 2 hours and 30 minutes, and then the I'm gonna do like that, and then the difference in boxes was 25 boxes. Oh wait, and 2 minutes and 30, 2 hours and 30 minutes is basically is 2.5 hours. So it took them 2.5 hours to unload an extra 25 boxes. That, and if you divide that by 2.5 hours, you get the rate of 10 boxes an hour. So now we have 10 boxes an hour. Now we want to know what is the total number of boxes that'll be unloaded from the truck at 7 p.m. And plus, since it says if boxes are unloaded from the truck at a constant rate, that means we know we use this rate. So easy way to do this is do 7 p.m., 1 p.m. That's a 6-hour difference, and there's 10 boxes an hour, so that's 60 boxes plus the existing 40 boxes, so that equals 100 boxes at 7 p.m. Now I'm going to be doing number 30 on this problem set. Yuna runs at a steady rate of 1 yard per second. Jessica runs 4 times as fast, so 4 yards per second. If Jessica gives Yuna a head start of 30 yards in a race, how many yards must Jessica run to catch up to Yuna? So basically, I'm just going to draw a diagram to explain this so you guys don't get what happened. Jessica's over here. Yuna is over here. They want to get to like someplace over here. The distance here is 30 yards. So we want to know how many yards will it take for Jessica to catch up to Yuna. I think the easiest way to do this is to first figure out how many seconds and then use that to figure out yards. So we know Yuna runs at a steady rate of 1 yard per second, and but she has a 30-yard advantage. So we can write that in the question. So let's say x equals seconds, or let's say s equals seconds. We know that it's s plus 30. If we want to figure out how many yards Yuna can run, because she has a 30-yard head start. And if you want to know how many yards Jessica can run, she can run she runs 4 yards per second, so 4s, but she doesn't have a head start. So the reason why we can equal these two expressions is because we want we want the number of yards that Jessica catches up to Yuna. So basically they're at the same number of yards. So now we just solve for s here, and it's simple math here at this point. So you subtract s on both sides. By the way, this is an s. I want to make that clear. This is an s. And that gives you 30 equals 3s. So that'll get 35. Let me fix that. 3s. And you divide each side by 3. And s equals 10. So 10 seconds. And now we just plug this back in to figure out how many yards it is. So let's plug into this equation. That's the easiest. So s is equal to 10. So 10 plus 30. And that equals 40 yards. So yeah, so I hope this gives you like a taste of these 3 topics in general. And like I said, there's a lot of practice problems here, and the answers are at the back. So I hope you guys go to Google Classroom and do a lot of these practice problems in order for you to like really make sure you get these topics, because the best way to study for the math section, and I said this in other videos, I'm gonna say it in I'm saying in every video, is to just keep doing practice problems so you can see patterns that emerge when you take the SAT, and you can see like what type of questions College Board do ask. Because a lot of the question types are similar. Obviously the questions aren't the same, but the question types are similar. So that's why you got to keep like exposing yourself to more practice problems so that you know how to solve each question type. So yeah, so that's basically it for this video. Thank you so much for watching, and good luck on your SAT studying.